We don't just use the zeros to find the polynomial functions and graph those, but we can also use them for, yeah, you guys are good, rational functions. What is a rational function? We've talked about them plenty of times. Maybe even mentioned them, pointed them out. Rational function consists of the form of f of x equals n of x over d of x. In other words, it's a fraction, it's a quotient, where both my n of x and d of x are polynomials. So having a quotient of polynomials, that particular function we call a rational function. Of course, d of x cannot equal 0, or not equal to 0 polynomial. The domain of a rational function? Except just like we did before, we know we can't divide by 0 whether or not I have numbers or whether I have variables or whether I have an entire polynomial. Right? The denominator can never equal 0, so we all start off with just all real numbers except for where I'm dividing by 0. Take a look at this. Here we want to find the domain. That's 3x over x minus 1. And discuss any behavior of the function near the excluded values. So first of all, what is the domain? Absolutely, because when x is equal to 1, we're dividing by 0, so well, what's happening by x equals 1 then? It's definitely an asymptote, absolutely. And that's something we're going to be looking at. If we take a look and plot a bunch of points, find out what that function looks like. So here I chose the values 0, 0.5, 0.9, 0.99. I'm just getting closer and closer to the number 1. Right? Coming from the left. Coming from the right, choosing values of 2, 1.5, 1.1, 1.01. And you guys can do these calculations in your head. We're coming up with f of x, right? Okay. So here, at x equals 1, when I'm taking my points coming from the left, starting off at 0, x equals 0, x equals 0.5, x equals 0.9, 0.99, getting closer and closer. What's going on with my f of x values? Going down where? So what is it approaching? Negative 3, negative 27, negative 297. So as x gets closer and closer to 1 from the left, it's approaching negative infinity. On the right side, I have those values of 2, 1.5, 1.1, 1.01. Our f of x was 6, 9, 33, 303. So as I get closer to 1, it's approaching. So we already said this is actually going to define vertical asymptote. When x equals 1, plot some of those points. And we come up with a graph that looks similar to this. Here we can take a look. The symbol here says as x approaches 1, and that minus sign indicating almost from the left. So as we approach 1, starting off with small values from the left side, so as we take coming this way, approaching 1, where's f of x going? To negative infinity. As x approaches 1 from the right, which we use as a plus sign. So x approaching 1 coming from the right, what's happening with f of x? And this is pretty much how we can define on what a vertical asymptote is. Basic definition of a horizontal and vertical asymptote: the line x equals a is a vertical asymptote. Of the graph of f, if f of x approaches either positive or negative infinity as x approaches a. So here we can see, right, over here, as x approached 1 from either the left or from the right, our f of x is approaching negative infinity and positive infinity, defining a vertical asymptote. Horizontal asymptote. When we say the line y equals b is a horizontal asymptote of the graph of f if f of x approaches b, as x approaches plus or minus infinity. So in other words, as x gets larger and larger, or as x gets smaller and smaller, is my graph approaching some y value. Do I have a horizontal asymptote here? At y equals 3. Over here we can see, as my graph approaches, as x approaches negative infinity, so as x gets smaller and smaller, my graph looks like it's approaching the line y equals 3. Likewise, as x gets larger, my graph f of x has flattened out quite a bit as it's approaching the line y equals 3. We'll find out how to come up with these exact values, not just by drawing them, but by the algebra and calculus. So these are the basic definitions of our horizontal and vertical, but how do we find them? First of all, here's some examples. In this first one, f of x equals 2x plus 1 over x plus 1. What is its domain? All real numbers except for 1. What is the vertical asymptote? X equals negative 1. Once again, what was the domain? What is the vertical asymptote? And we also have we see a horizontal asymptote. As my graph approaches negative infinity, it's approaching the line y equals 2. As it goes to positive infinity, as my x gets larger and larger, it's approaching positive 2. I don't have to have a vertical with a rational function. In this case, 4 over x squared plus 1. What is the domain? All real numbers, absolutely. Rational function, we say we throw out anything in where we divide by 0. When would I be dividing by 0 in this case? When is x squared plus 1 equal to 0? Nowhere, at least not for real numbers, right? Only for imaginary can I have x squared plus 1 equal to 0. As Nicole said, this is where we have all real numbers. Do I have a vertical asymptote? No. Over here, this last one, you can see it doesn't have to be one going to positive infinity, one going to negative infinity. In this case, at the line x equals 1, the asymptote x equals 1, both of them are approaching negative, positive infinity. So, how do we find these? Vertical asymptotes. Okay, we have our f of x equals n of x over d of x. No common factors. A graph of f of x. Has vertical asymptotes where? You guys just told me the last ones we were looking at. How did we come up with those vertical asymptotes in the last example? Other than just looking at them. Here my denominator is equal to 0, right? I set that polynomial in the denominator equal to 0. Well, we do that same thing where we come up with the domain, right? We're throwing out those points. For my vertical asymptote, I'm just setting that equal to 0, and that becomes x equals whatever that is. That becomes my vertical asymptotes. How do you find the zeros? Leave x equal to 0, and you have to that's all there is to vertical asymptotes. Once I find the domain, pretty much I'm already done, right? For horizontal, though, my horizontal asymptotes, same thing. We have that n of x over d of x. Here I've expressed my n of x as a polynomial using coefficients of a and a degree of n. And the denominator expressed as a polynomial with coefficients of b that has a degree of m. So for our horizontal asymptotes, when we want to find the horizontal asymptotes, all we're doing is we're comparing the powers, or just the degrees. So all I'm going to be doing is comparing my n and my m. I'm not looking at anything else. I'm just looking at the exponents, the degree of that particular polynomial. So for here, my n, for my n of x, and my m for d of x. These are just the powers, my degree of that particular function. 3 different cases, right? N is less than m, n equals m, or if n is larger than m. So, do I have a larger degree polynomial in the denominator? Do they have the same degree, or is the numerator the larger one? First case, my denominator has a larger power, so if n is larger than m, the graph of f has a line y equals 0 is a horizontal asymptote. So the x-axis becomes that horizontal asymptote. If n equals m, then our asymptote becomes y equals a sub n over b sub m, which is just the ratio of our leading coefficients. Like we have here, written up here, if my n and m are equal, I'm just taking an over bm. And if n is greater than m, no horizontal asymptotes. I know that's a disappointing one for you guys when that happens, but sometimes there won't be any horizontal asymptotes. So, here we're going to find all the asymptotes. First off, what is the domain?
Except for one.
1 and negative 1.
1 and negative 1.
Yes.
I mean to solve for x squared minus 1 equals 0, right? X squared minus 1 equals 0, we'd have 2. So my domain all real numbers except for negative 1 and 1. What about my vertical asymptotes? What's the point?
X equals 1.
Absolutely. Once we find the domain, writing out the vertical asymptotes, it's the exact same thing. Right? Whatever point we excluded, x equals 1, or x equals negative 1, and x equals 1, so are my vertical asymptotes. Horizontal? What case do we have here? So when we had the same, what did we do? We had y equals the ratio of the coefficients, right? So what was my coefficient on my numerator? 5. Denominator? 1. So I wind up with y equals 5 as my horizontal asymptote. X equals negative 1 and x equals 1 as our verticals. So we have those 3 asymptotes. Exciting. I can tell. What is my domain? Except for what?
Negative 2.
How'd you do that?
You said x squared minus x minus 6 equals 0.
So by going ahead and finding out where the denominator is equal to 0, you can say, okay, I need to eliminate those points, positive 3 and negative 2, but everything else is perfectly fine, so all real numbers except for negative 3 and positive 2. And let's real quick change this to x squared plus x minus 2. Vertical asymptotes.
X equals negative 3.
So, can I factor that numerator? Into what? Do they have a common factor? Now, what is my vertical asymptote? X equals 3. My point, my negative 2, it's still undefined at that particular point, but that is not an asymptote. Find the asymptotes. Again, it only works when there are no common factors. So if you have something that you can factor it out, find out what cancels out, And from there, you can say, okay, now I'm going to look at my horizontal and vertical asymptotes. Domain, it's still going to be undefined at that -2 and that +3, though. So when you find the domain, your vertical asymptotes will always come from those excluded points. It may not be all those excluded points, but it will always come from there. So here we have the vertical as x equals 3. Horizontal, what are we comparing? Absolutely, we have that n equals m, as in the last case. So we have that y equals 1 over 1, or just y equals 1 as our horizontal. Question? What is my domain? Once again, right, to find that domain, find out whether the denominator is equal to 0. We said that x squared minus 1 equal to 0, giving us that +1, -1. Are there any common factors? No. So we don't have to worry about anything from there. So if there's no common factors, what are my vertical asymptotes? X equals -1 and x equals +1. So what about my horizontal asymptotes? Since my n is greater than my m, no horizontal asymptotes. I know, that's the disappointing, right? But fair enough. When we have n is greater than m, there still is another case. I know, because I know you guys were disappointed in not having any horizontal. So there is one particular case where n is greater than m, and we come up with a different asymptote. It's called a slant asymptote. Okay, does that make you guys feel better that there is something? No?
Yes.
So if the degree of n, my numerator, is exactly 1 more than the degree of the denominator, the graph of the function has a slant or oblique asymptote. So for example, here we have the graph of f of x equals x squared minus x over x plus 1. Definitely no horizontals, since my numerator is larger than my denominator with degrees, right? But it is 1 more. I have a first degree in the bottom, and in the numerator I have a second degree, which gives me that slant asymptote of y equals x minus 2. How do we come up with that slant asymptote? Looking here. As Caden said, use long or synthetic division. And the quotient is the slant asymptote. So, at the one we just looked at, f of x equals x squared minus x over x plus 1. If we do that division, should we do long or synthetic? Okay, using what then? -1. I have a remainder of 2, right? What's the remainder of 2? So, when we did the division, what do I have now? X minus 2 plus 2 over the divisor. My slant asymptote is only concerned with the quotient. So it's just going to be y equals what? X minus 2. I do not have to worry about the remainder at all. You can see as x gets larger and larger, what's happening to my remainder? And so it's basically going to 0. So that's why we can ignore the remainder, and we're just looking at the quotient. So here we have y equals x minus 2 becomes my sign asymptote. So here we have f of x equals 3x squared plus 1 over x. What is the domain? All real numbers except for 0. Absolutely. 3, are there any common factors?
I don't know, honestly.
Now you can look. Are there any common factors? Can I factor 3x squared plus 1? No. So that's just 3x squared plus 1 over x, so no common factor, so we don't have to worry about coming up, excluding anything else as far as our horizontal and vertical domains, or horizontal and vertical asymptotes. So what is my vertical asymptote? Kyle? X equals 0. Okay. Remember, we're just going to take that point that we excluded from our domain. That becomes my vertical asymptote, x equals 0. Do I have a horizontal, James? No. In this case, we have n is larger than m, so I do not have a horizontal. Do I have anything else in me? Do I have a slant asymptote? Absolutely, I have a slant asymptote because my second degree in the top, first degree in the bottom, it is one more degree. When it's just that 1 degree difference, we know we have a slant asymptote, which tells me we need to do that division. X into 3x squared plus 1. What should we do? I mean, 0 is 0, so you can't divide by 0. You can't use synthetic. You cannot use synthetic division to divide this. What is a 0? 0 is 0. You can't divide by 0. Right, that's synthetic. This one doesn't even require to use synthetic or long division. Here you just look at this. Right, isn't that what we have here? When it's something that basic. So, knowing this, what do I get for my sign asymptote? Y equals 3x. The same thing as just taking the quotient and don't even looking at ignoring the remainder. Right? All these domains are looking very similar. I just now realized it. Domain, all real numbers except for 1 and negative 1. Those are no common factors. X equals negative 1 and 1. Don't forget the x equals, folks, right? Because the asymptotes are lines. Do I have a horizontal dose? Aubrey, do I have a slant? Absolutely. Since I have a third degree, second degree, a difference of 1, I have a slant asymptote. So now we have to do division. Can we use synthetic? No. Because it's x squared minus 1, right? I can only do that with x minus a. So Stick to what you first said. Because now what do I have here? First degree. And my divisor is what? Second degree. So again, once my divisor is larger degree than what we have left, that is my remainder. Right? Because now I just have x. This is what happens when I divide. What are we only concerned with? If you got straight just from the quotient, again, ignoring the remainder. Questions, folks? We're going to do lots more of this stuff on Monday, in particular when we do the graphs of all this. If you can see in the notes. The more you get done now,